Today we are going to learn experiment in physics of class 12. This is the second experiment, we can say. We had already given the first experiment video. This is the second experiment, and its aim is to find resistance of a given wire with the help of a meter-bridge, and hence to find its resistivity. Now we have to understand what is meter-bridge, how it looks, and what is the principle of the meter-bridge. So this is meter-bridge. I will show you the apparatus. These are the thick strip, copper strips are there, connected like this, and this is 1 meter long wire AB. There are two gaps. In the first gap we have connected resistance R, that is known value, and in second gap this is resistance S, unknown value. And there is a jockey from C to D, there is a jockey through the galvanometer, and this jockey point is movable point. D is a variable point. We can slide on the wire AB to get the zero deflection in galvanometer. This length is L and we get the value of S. Now we have to understand what is balanced Wheatstone bridge. It is a combination of four resistors R, S, P and Q. You can see R and S is here, and this is P. One side of the wire is P, another side of the jockey of the remaining wire of 100 centimeter long. If this is L, then this is 100 minus L. So L is P, the resistance of the wire L is P, and the resistance of the remaining wire 100 minus L is Q, and D is the variable point. So in balanced condition, the galvanometer shows no deflection, and then we can write this relation R divided by L equal to S divided by this length 100 minus L, and we find S. 100 minus L divided by L into R. After finding S, we see here the resistance is equal to rho L upon A. You know the formula. This L is the length of the wire here, which is connected in S, and then we calculate the resistivity rho. The final formula is S into pi d square by 4L. Here D stands for the diameter of this wire. Now come to the real apparatus. This is the real apparatus. You can see the strip, thick copper strips are there, and between the gap I have connected one resistance box, and this key is 1 ohm key. I have taken it out, 1 ohm, or different keys are there. You have to take the appropriate key out. Any key we can take out for measuring the resistance of this wire R. S, this is S, unknown wire. We have to measure its length and we have to measure its diameter as well. We measure the length with simple scale and diameter with the help of screw gauge. After finding that length and diameter, now you come to the experiment. This is a jockey, sliding contact, you can see. If we put the key on, the key is on. This is battery illuminator, and we have taken 4 volt from here, and the current is coming. This is switch is on, and jockey is here. So galvanometer is not showing any deflection. Now we have to see that for the safety of this galvanometer, we have connected this resistance box, and we have taken the 2000 ohm. This is 2000 ohm key. We have taken out. So 2000 resistance is in series with the galvanometer. This is to decrease the current in the circuit and for the safety of the galvanometer. This resistance will not be taken into account for the measurement of the resistance of this unknown wire. This is only for safety of the galvanometer. Now when we touch we have taken R as 1 ohm, S is unknown, and we touch the jockey at any point on the wire, meter-bridge wire, you see the deflection. Deflection is going towards right, and deflection now it is coming towards to the center. You can see the deflection is coming. I am moving the jockey here, and the deflection is coming at the 0. Now this is 0 deflection. So this point we have to see, the reading is 55 centimeter here. Galvanometer deflection is 0, reading is 55 centimeter. Now if I move this side, again you can see the deflection is not 0. So at one side deflection is going left, on another side deflection is going right. Deflection is going towards right. This side right deflection and this side left deflection, and at 55 centimeter or any value it may be. Here for this experiment when R is 1 ohm, so this is 55 centimeter null point. So 55 centimeter is our L and 1 ohm is our R. So R by L equal to S. S is unknown divided by 100 minus L. So that is the reading we have to write here. Serial number 1, resistance is 1 ohm, length is 55 centimeter, and put the value of L and find the S. After finding S, you again put it here and you will get the value of resistivity. Okay, now suppose for second reading, what we do? We take one more, 1 ohm is out and we are taking 0.2 ohm here, 0.2 ohm. So total resistance is 1.2 ohm. We have increased the resistance, then the value of L will increase. So initial was 55, now you can see from here I am sliding the contact and now you can see the reading is coming at 58.5 centimeter. R, the value of R is 1.2 ohm and the value of L is 58.5 centimeter. Again, suppose we decrease the value. I am putting this key back again. 1 ohm is also back. I am taking 0.5 plus 0.2, 0.7 ohm. 0.7 ohm I am taking. R is decreased, so L will decrease. Now you can see the value, the null point here. I am getting the null point here, 0. So see that galvanometer deflection is 0 at 42 centimeter. So when we have taken R as 0.7 ohm, the value of L is 42 centimeter. Okay, so we have to select that value of R which gives the deflection between the 40 centimeter and 60 centimeter, that is at the center of the wire. Why? The deflection should be at the middle of the wire to reduce the effect of error. So what is the error? Error, you can see 1 centimeter. The wire is connected here. This is the end error. So this extra length is not taken into account on either side. So on either end there is extra wire. So that extra wire's resistance is not taken into account and it causes error. To minimize that error, effect of end error, we require the deflection should be in the middle of the wire, that is between 40 to 60 centimeter. If it is nearly at 50, it will be better at best reading and error, chances of error will be minimum. I think you have understood what I want to say here and how this experiment can be performed. Thank you very much.